Section 6.5 is on operations with radical expressions. And this is going to be very similar to what we went over in Algebra 1, dealing with radicals and all of the different things that you can do with it. The big difference here is we're not just going to be dealing with square roots, we're going to be dealing with nth roots. So our index is not going to be a 2, it's going to be, oh, it can be a 2, but it's also going to be a number greater than 2. So if I have the nth root of a times b, I can just break that apart. That's the same as the nth root of a times the nth root of b. So if there's multiplication under the radical, you can split them up. Same thing is true with division. So the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. So that fraction underneath the radical sign, you can break it up. Recall also that a fraction cannot have a radical in the denominator. So we can't have a square root in the denominator, or a cube root, a fourth root. No radicals in the bottom of a fraction. To eliminate the radical, we call it rationalizing the denominator. We turn that irrational number in the denominator into a rational number. So we have to multiply it by something in order to make that denominator be an exact root so that we can take the square root of it. We'll see an example like that. So here's several examples. Let's simplify. So I have the square root of 72, x to the 8th, y to the 5th. This is a square root, so my index is 2. So I'm going to start, there is not an exact root of 72. There is of 64 and there is of 81, but not 72. So I'm going to have to do a little factor tree on this. And what I like to do is, instead of coming up with all of the numbers, I could have started with 8 and 9, but I'm going to look for numbers that are perfect squares that go into 72. So 72 is the same as 36 times 2, and I know that the square root of 36 is 6, okay? But I can't take the square root of 2, so that's got to stay there. So this square root of 36 is going to turn into a 6 in my final answer. X to the 8th, this is actually kind of nice because this is a 2, that's an x to the 8th, and I'm going to divide that 8 by 2. That's going to give me an x to the 4th. Actually, I don't want to forget about this guy, so I'm going to circle him. He's going to have to stay in the radical. Y to the 5th is the same thing as y to the 4th times y to the 1, basically. Remember that when you're multiplying powers, you add their exponents. So y to the 5th is the same as y to the 4th times y to the 1. Y to the 4th, I can take that 4 and divide it by the 2 out here. That's going to give me y squared, and this y to the 1 is going to have to go inside the square root sign. So square root of 2y. Okay, so do I need absolute value bars? I took an even root of an even power, but I got an even answer, so no. I took the even root of an odd power, so no. Remember, absolute value is if you do an even root of an even power and you get an odd answer. So 6x to the 4th y squared times the square root of 2y is my final answer. I know it doesn't look very simple, but it is technically simplified. Okay, let's try number 2. The 4th root of 162, a to the 6th, b to the 13th, c. So 162, first thing that jumps out at me is that is divisible by 2, which gives me an 81. 81 is 9 times 9. That's 3 times 3. And now this is important because I'm looking for a 4th root. I'm going to buddy up by 4s. So notice I have 4 3s here. So that's going to give me the ability to have a 3 out front. Okay, but this 2 is all by himself, so he's going to have to stay in the radical. A to the 6th. A to the 6th is the same as a to the 4th and an a squared. So this a to the 4th, I can take the 4th root of that, okay, which will give me an a out front, but then I can't take the 4th root of this, so that's going to have to stay put. My b to the 13th is the same as b to the 12th times b to the 1. Now you're probably wondering, why did I say 12? Because I know that 12 can be divided by 4. So this is actually going to turn into b to the 4th root of b to the 12th is actually going to give me a b to the 3rd. And then this b to the 1, I can't take the 4th root of that, so that's going to have to stay there. And then I have a plain old c. I'm kind of circling some of the things that are going to need to stay underneath. So underneath the radical, so I have the fourth root of 2, and then I'll have an a squared, and a b, and a c. So those were the things that I couldn't take the fourth root of. Okay? So let's go back and check and see if we need absolute value bars. So I am taking an even root of an even power. Okay, do I have any even powers here? I think an even root of an even power. I took the fourth root of a to the fourth and got an a to the 1, so I will need bars on my a, and none of my other powers were even, so I'm good. You know, if that's a little confusing, let's try it another way. I'm going to actually, instead of breaking it down into all of these things raised to powers, I'm going to do it this way. I can rewrite that as the fourth root of 2 times 3 times 3 times 3 times 3, okay, times 6 a's. Uh-oh, I just got myself into trouble here. I'm going to have to do 13 b's. Do I really want to do 13 b's? 1, 2, 3, 4, 5. Okay, I'm going to continue on the next line. 6, 7, 8, 9. Maybe I should have put one more over here because, no, I'm going to have to do them by 4s. Hold on. 2, 3, 4, 8, 9, 10, 11, 12, 13, and a C. Okay, so all of that is underneath the radical. Just imagine that continuing. Now, since it's a fourth power, I'm going to look for groups of 4. So there's a 4. That's how I got that 3 out front. Here's 4 A's. That turns into this 1 A out front. The B's. There's a group of 4 B's. There's a group of 4 B's. There's a group of 4 B's. So I have 3 groups of 4 B's. That gave me this B to the 3rd. This B has no buddies. This C has no buddies. So underneath the radical, I have left a 2, an A squared, a B, and a C. 2A squared BC. So you can do it either way. It's just a real pain if you have to do something like writing out 13 B's. Now, this one's a little more complicated. I have to rationalize the denominator because I can't have, in the past we've said can't have a square root in the denominator. I can't have any kind of root in the denominator. And in this case, I have a cube root. So what I really want my denominator to be, I need to get the denominator to, I want to get my denominator to be 5y. Okay? Right now what I've got is the cube root of 5y. What I really want is the cube 5y is going to be equal to the cube root of 5 cubed and y cubed. Okay, let me go back and say that again. So I can't have this cube root in the denominator. I need something plain old just like 5y, and I chose 5y because that's what's under the radical. That's the radicand. So in order to get it to be 5y, I need to have the, since it's cube root, I need to have the cube root of 5 cubed, because that's going to give me a 5, and the cube root of y cubed. That's going to give me a plain old y. So what do I have to multiply the cube root of 5y times to get this? So the cube root of 5y, if I multiply that by the cube root of 5 squared y squared, okay, so remember I can just multiply. That's going to give me 5 times 5 cubed, or 5 squared is going to give me 5 cubed. Y times y squared is going to give me y cubed. And that's going to give me the 5y that I'm looking for, because the cube root of 5 cubed is 5, cube root of y cubed is y. So this is actually, I'm going to circle them in pink here, this is the key. This is what I have to multiply my denominator by in order to rationalize it, in order to get rid of that radical sign. So remember, if I multiply the denominator by that, I also have to multiply the numerator by the same thing. Okay. Now that looks really messy, but let's do the bottom first. I already did the bottom. I already know what that's going to be. That's just going to give me a 5y, because that's going to give me a 5 times 5 squared is 5 cubed. The cube root of that is 5. Y times y squared is y cubed. The cube root of that is just y, and that's perfect. That's exactly what I want. Now I can just multiply the stuff underneath the radical here. So I'm going to have the cube root of something. Okay, 6 times 5 squared. 5 squared is 25. 6 times 25 is 150. X squared times y squared is just x squared times y squared. And that's my final answer. I'm going to clean that up a little bit. Okay. And that's simplified because we have gotten rid of the radical in the denominator. Let me go through that again. So I can't have this radical in the denominator, so I have to figure out what do I have to multiply this denominator by in order to get rid of the radical and get to just a 5y. So since I need a 5 cubed, I have to multiply it by 5 squared. Since I need a y cubed, I have to multiply it by y squared. So here we have 2 times the 4th root of 8x cubed y squared times 3 times the 4th root of 2x to the 5th y squared. Now, since they're both 4th roots, I can just multiply everything and then simplify. So I'm going to multiply my numbers out front. That's going to give me a 6. And then the 4th root of, now let's just multiply the radicands. 16, x to the 8th, remember add the 3 and the 5, y to the 4th. Okay, so multiply the stuff out front, multiply the stuff underneath. Now let's simplify this. So this is going to be 6 times the 4th root of 16. I'm going to simplify 16 here. I know that's 4 and 4. I know that's 2 and 2. Okay, so 4th root, that's just going to give me a 2 out front. Okay, so this is going to, let's keep that 6 there. The 4th root of 16 is going to turn into a 2 out front. The 4th root of 8x to the 8th, I can do my division trick. That's going to give me an x squared. And the 4th root of x to the 4th, 4 divided by 4 is 1. That's going to give me a y. I can multiply those together. 12 x squared y. Let's check and see if we need any absolute value bars. So I'm looking for even, even, odd. Yes, I took the even root of an even power, but I got an even answer for my x's. I took an even root of an even power for my y's, and I did get an odd exponent there, so my y has to be between absolute value bars. So there's your final answer. Okay, and you might remember this from Algebra 1 as well. To add or subtract radicals, the radicands must be exactly the same. The stuff underneath the radical must be exactly the same, and then you can combine the numbers out front, the coefficients. So let's simplify each one of these. So 12 is 4 and 3. The square root of 4 is 2, so that's going to give me the 5 out front, times this 2, times the square root of 3. Square root of 12 is 2 square root of 3, plus, let's do this one, that's a 3 and a 9. Square root of 9 is 3, so this 2 times that 3, and that guy has to stay the square root of 3. And then that's going to be minus 128 is actually 64 times 2. Square root of 64 is 8, and that's a square root of 2. Now let's multiply. This is 10 square root of 3 plus 6 square root of 3 minus 8 square root of 2. I can combine the so-called like terms, the ones that have exactly the same radicands, which are the square roots of 3. So this is going to give me 16, because 10 plus 6 is 16, square root of 3, minus 8, square root of 2. Multiplying, now notice I have what looks kind of like a binomial. I have a radical times, or plus another radical in parentheses, and then that's multiplied by 2 terms that are subtracted. To do this, I'm going to FOIL. Okay, so when I do my first, I do my first. So 2 square root of 3 times 3 gives me 6 square root of 3. Do my outer. That's going to give me 2 square root of 3 times the negative square root of 3. So that's going to give me a minus. Square root of 3 times square root of 3 is 3. Times the 2 gives me a 6. Inner. 3 square root of 5 times 3 is 9 square root of 5. I'm sorry, 3 square root of 5 times 3 is 9 square root of 5. And then when I do my last, it's going to be, it's actually going to be a minus 3 times the square root of 15. And do I have any, I don't have any like terms to combine, because here I have a radical, square root of 3, no square root, square root of 5, square root of 15, can't combine anything. If you did have some radicals that were the same, you could combine like terms, but nothing there, so I'm done. Let's try another example of that. Again, we're going to FOIL. Okay, I'll do my first. So 8 times 8 is 64. And I can't do all this in my head. Square root of 5 times square root of 5 is 5. Okay, I'll grab a calculator later. Outer, that's going to give me 48, positive 48, square root of 15. Multiply the 8 and the 6, multiply the square root of 5 and the square root of 3. Inner is going to give me a negative 48, square root of 15. Oh, I'm liking that. Whoops. 48 square root of 15. And then doing my last, negative 6 times positive 6 is a negative 36, and square root of 3 times square root of 3 is 3. What I like here is that these guys cancel each other out. That's lovely. 64 times 5 is 320, minus 36 times 3 is 108, for a final answer of 212. Now let's go back and look at this problem. Notice they both, inside the parentheses, they both started with an 8 square root of 5, and they both ended with a 6 square root of 3. One's a minus, one's a plus. We're going to use that in the next problem. So it's the same terms, but one's a positive and one's a negative. Notice the cool thing that happened was we had some canceling out in the middle there. And actually we are going to use that in this problem. That's called the conjugate. If there's a radical in the denominator and a plus or a minus between them, like we have here, square root of 5 minus square root of 3, we're going to multiply by the conjugate, which is exactly what we had up here. Exactly the same terms, but one with a plus and one with a minus. So to simplify this, I'm going to multiply it by square root of 5 plus 3, square root of 5 plus square root of 3, over square root of 5 plus square root of 3. Why did I choose that? Because there's a square root of 5 and a square root of 3 in the denominator already. Instead of the minus, I make a plus. On the top, I'll distribute. I'll go ahead and write out the steps here so you can see what we're doing. And then on the bottom, I'll be foiling. Okay. On the top, I will get square root of 10 plus the square root of 6. And then on the bottom, because I made it work this way, this guy and this guy, when I do my inner and I do my outer, they're going to cancel each other out. Notice this is going to give me a negative square root of 15. This is going to give me a positive square root of 15. So really all I have to do is my first, which is going to give me a 5, and my last, which is going to give me a minus 3. Square root of 5 times square root of 5 is 5. Negative square root of 3 times a positive square root of 3 is a negative 3, or a 2 on the bottom. Don't do any canceling, because you can't cancel stuff inside and outside. And there's your final answer. So a lot of these problems were very similar to stuff that we did in Algebra 1 with square roots, but now we're extending that idea to nth roots so that we can involve other